What local really means, MongoDB versus Wiki. When the book local says local change, it does not mean small or fast. It means the database can apply the update by touching a bounded, known part of the stored value without understanding global meaning. Local equals structurally bounded, non-local equals semantically global. MongoDB what local means here. Example, user next line key value name Alice next time key value tags RA admin editor closing. Local update $push key value user tags owner. Why is this local? Mongo knows the structure. It can jump directly to user tags. It does not need to parse or reinterpret the whole document. The operation is deterministic, position aware, structure aware. Mongo doesn't care what owner means, just where to put it. Wiki edit, why it's not local. User A, insert a sentence in paragraph 3. User B, delete paragraph 2. Now paragraph number shift, meaning changes, intent conflicts. The system must understand text semantics, track intent, merge meaning, not structure. This is global, not local. Key insight, local updates operate on structure, non-local updates operate on meaning. Local in Redis, even cleaner. INCR counter, Redis knows exactly which byte store counter, applies a CPU transaction, done. So this is like the internal hardware that makes it, the atomicity. It provides those local structure. Then done, no parsing, no structure rebuild, no semantics. That's maximally local. Third, Riverpad, does it use nodes, graphs, memoization? Short answer, yes, but not in the naive textbook DSA way. Let's be precise. Riverpad uses a dependency graph. Each provider is a node. Edges mean this provider depends on that provider. Example, auth provider to profile provider to UI provider. So that what provides this dependency graph. The profile provider depends on auth provider because that's its parent, and the UI provider depend on the profile provider. In our profile app, that's actually the page. So this is a directed acyclic graph DAG. So directed to dependency direction, then acyclic to no loops allowed, because you cannot like recompute or update a value if it's the same value. What does memoize means here? It does not mean store everything forever. It means cache the last computed value as long as dependencies are unchanged. Riverpad rule, same input, same output, reuse result. That's pure function memoization, not object caching. What changes when a provider updates? Let's say final user provider equal provider, argument user, argument rep, open semi-curly bracket, next line return, ref.watch, argument auth provider user semicolon. Now, if auth provider emits the same user, then user provider does nothing. If auth provider emits a different user, then user provider recomputes. Then only its dependence update. This is not React diffing. React compares trees, reconciles UI nodes. Riverpad recompute values in a graph, UI just descends. Fourth, is Riverpad a user space program? Yes, 100%. This is important. Riverpad runs entirely in user space inside your app process. It is not an OS service, not a runtime feature, not a VM primitive. So it's not a runtime, that's clear. It's a library. So run entirely in user space. It's a library written in Dart implementing a graph management, dependency tracking, memoization, lifecycle control. Same category as Redux, just smarter graph semantics. What language is Dart compiled to? This is a big clarity unlock. Dart has multiple compilation targets. Flutter mobile or desktop, Dart to AOT ahead of time, to native machine code, ARM/x86. That's why you can run the same, you can write the same Dart and then use it in mobile. It runs directly on CPU, no JavaScript involved. It uses LLVM based toolchain. So you don't need to like have, a progressive web app or designing to the web as well, or making your CSS adapt with the mobile because as you can see, it directly compiles to mobile. Now, Flutter Web, for Flutter Web, it's a different story because there's a Dart to JS converter. Because again, web runs mainly on JS and then that JavaScript ran on the JS engine. So the Flutter Web is compiled to JavaScript, then that JavaScript is what's running on your web. So yes, Dart becomes JavaScript on the web. No, not on mobile. Flutter development mode, Dart to JIT or just in time, and VM bytecode. So a virtual machine bytecode will run on your development mode while you're using Flutter-D Chrome or launching emulator. That's why hot reload works there. Like when you change something and then reload, you will be able to see that what RiverPad really is, deep but simple. RiverPad is best understood as a reactive memoized dependency graph executor. It answers what depends on what changed, what must recompute, what can stay cached. That's it. No magic, no threads, no compiler trick. 7. Correcting subtle misunderstanding. Important misunderstanding. RiverPad stores state like Redux global state. Reality Redux, one global object. RiverPad, many independent nodes. Global emerges from graph reachability. Misunderstanding. Memoization is just optimization. Reality, memoization is semantic correctness under reactivity. Without it, infinite loops. So the memoization is what prevents that infinite loops because it just avoid the computation of the same output. Unnecessary recomputation, UI trashing. Misunderstanding. Local updates are about size. Reality, locality is about bounded structural scope, not bytes. Tie back to your earlier atomicity question. Local updates are what make atomicity possible. Atomic ops work when the engine owns the mutation, the scope is bounded, the meaning is irrelevant. That's why Mongo $push is atomic, Redis INCR is atomic, Wiki edits are not. So the local updates or its hardware internal structure is what makes it atomic. Now the engine owns the mutation, the scope is bounded, and the meaning is relevant because it's run entirely on the engine or it's in local control. Now Mongo $push is atomic. So that syntax is atomic because it's running on MongoDB storage engine, and Redis INCR is atomic. Wiki edits are not, same pattern, different layers. So important clarification, non-relational database also provides atomicity, not just relational. That's why Mongo provided that. So interview-ready explanation. Local updates are operations that touch a bounded, structurally known part of data. Systems like MongoDB, Redis, and RiverPad rely on locality to safely apply atomic updates or memoized recomputation. Once updates require global semantics interpretation like free-form text editing, atomicity and memoization breakdown and conflict resolution is required. Why the book says the way the command is constructed allows atomicity. The key phrase is constructed. What the book is saying is not SQL magically makes things atomic. What it's saying is some operations can be expressed in a form that the database engine can execute entirely inside itself without exposing intermediate states. This line So some operations such as this interface or like command can execute inside entirely inside itself because some database do not provide this level of atomicity or like kind of like this the same command that will allow it to be atomic. Why? Because the old value is never returned to the application because of the structure of your command. The new value is never computed in the application. The entire transformation is declared, not orchestrated. You're describing what to do, not how to do it step by step. it's up to the storage engine to provide that atomicity. That distinction is huge. Why not all databases support this kind of atomicity? Now we get to the subtle part of the book is warning about. Atomicity requires three things together. First, a declarative update language. Second, an execution engine that understands the operation. Third, concurrency control at the storage level. Many systems lack one of these. Example 1, key value stores, naive 1. Some database only support get key, next line put key value. There's no syntax for put key equal all underscore value plus 1. So the only way to increment is read, modify, write, not atomic. Example, the ORM is what the book is warning about. An ORM often generate codes like const row equal await.db.find argument ID next line row.value plus equal to 1. So as you can see, it has the same syntax as Python increment. Next line await db.save row. So you're putting it in the application control. Therefore, even though this looks like high level, it's still a read modify write cycle. The ORM has already read the value, already left the database, already lost atomicity. That's why the book explicitly calls ORM out. Third, why update value equal value plus 1 avoids clobbering. Let's connect to the book's praise. The second write does not include the first modification. That happens when both writes are based on the same old value. But in update counters, next line set value equal value plus 1, next line where key equals foo semicolon. Each execution reads the current committed version. It applies the increment after previous commits. So this interface, each execution of this is atomic because it reached the current committed version. It means it doesn't sniff in the middle of that transaction, and then it applies the increment after previous commit and serialized access via locking or MBCC. So instead of 5 to 6 and the next 5 to 6 again, because you get that trace kind of like non-atomic update, you get 5 to 6 to 6 to 7, no clobbering. Why JSON updates and Redis are mentioned? The book is showing the same idea in different data models. In MongoDB, you have $inc colon key value first value colon 1, next line push colon key value first item colon x. These are atomic because Mongo understands the structure. The mutation is localized, kind of like updating the in JSON object, kind of like updating the known key and value, and then the engine applies it internally. In Redis, inc counter, next line say add queue score member. So this is how Redis internal interface does this. Redis literally run this on a single thread. So atomicity is trivial or doesn't matter because since it's a single thread, no other threads could snip into the middle of that execution. Now, why wiki edits are different? This is a deep boundary. This sentence matter a lot. Not all writes can easily be expressed in terms of atomic operation. Why? Because atomic operation requires deterministic, local, structure-aware, order-independent updates. Text editing is semantic, non-local, context-dependent, intent-based. There's no single plus one minus like operation that captures insert this sentence here, but only if that paragraph still exists. That's why version vectors, OTCRDTs exist. Atomicity simply doesn't scale to meaning. 6. The deepest misconception to correct. This matters later. Subtle misunderstanding. Atomicity is a property of the database. That's not correct. More precise, atomicity is a property of an operation as executed by a system. Kind of like it is being defined by ACID property. It can be applied not just in database but in user space code as well. Some database can execute one command atomically, such as that SQL command, and some and another non-atomically, because that command, could not be crafted to be atomic in that database. It depends on how the operation is expressed, where the logic runs. So as you can see, how the command or operation is expressed and where the logic runs, what storage engine, and who owns that critical section. So that's where the threads or the critical section concept in OS comes. How this connects to everything you asked earlier. This ties directly into Redux. Reducers are atomic because only one reducer runs at a time. State is replaced, not mutated. So one reducer, kind of like one thread, works, or one reducer runs at a time, and it is version. RiverPad providers are atomic per node because recomputation is isolated via memorization. Dependencies are tracked by the RiverPad so that it will return the same value if it's the same value, and no interleaving so that we avoid loops. Supabase or SQL updates are atomic per row or document. Engine controlled, not app controlled. So it's being controlled by engine because remember, we have a command and then a query planner, and then the engine basically will decide how it will execute. Same idea, different layers. Interview ready sentence. Atomicity depends on whether the operation can be executed entirely within data stores. Concurrency control. Expression like value equal value plus 1 are atomic because the database owns the full read, modify, write cycle. Whereas ORM level logic breaks atomicity by moving part of the operation into application code. So first, what atomic actually means precisely. Atomic does not mean fast. Atomic means indivisible. From the outside, it either happens completely once or does not happen at all. There's no observable intermediate state. So atomic is not equal value plus 1. Atomic equals to no one can see or interfere with the middle. Second, why value equal value plus 1 is not atomic in application code. So if you apply this value or value plus 1 in the application code, since application code is imperative, it would not apply. Imagine this code, logic in JS/Flutter/React. You have const value equal read argument value semicolon, next line const new value equal value plus 1 semicolon, next line write argument new value semicolon. Two users at the same time. User A reads 5, user B reads 5. The next line user A writes 6. The next time user B writes 6, you get a lost update. So you got a random bug now in the user space if that happened. This is a read modify write cycle and it's not atomic. This is the same class of bug as race conditions, stale state, inconsistent UI updates. Why the SQL version is atomic? Because update counters, next line set value equal value plus 1. The next line where key equal foo semicolon. Key inside, this is the part people miss. The database execute this one operation inside the storage engine. Not first read row, second return to app, third app computes, then fourth app writes back. Instead, you lock row and then you provided the read value and then you add one or increment it and then you write value and then you unlock row. No other transaction can observe the row in the middle, or no other transaction can snip on that critical section. That's what makes it atomic. Fourth, is it atomic because of the plus 1? No, this is very common correction. It's not atomic because it's plus 1. It is atomic because the database engine controls the entire operation. The operation run inside the transaction. So that operation runs inside a transaction. It provides like isolation, consistency, what is the A there? Durability. It also provides like atomicity. So you could write set value equal value times 7 minus 3. Still atomic. The math is irrelevant. ownership of the operation is everything, or how the SQL engine ultimately run it is what matters. How the database enforces this, connect to your earlier question. This ties directly to pointers, CPU pages, CPU caches, execution units. Inside PostgreSQL, simplified, you have SQL statement or the command or the operation. It will become a query planner on how the storage engine will execute it under hood, and then will execute the executor. After it execute, it will provide a row level lock or MVCC write intent. So it's kind of like the same concept with providing memoization or cache before you return it to user. Like kind of like you have those security, and then it will be page in memory, and then it will be CPU executes instruction. During this, the row is exclusive. Other transactions must wait or retry. So that's the key. Other transaction must wait or retry. Like it will not be able to sniff that. So the way to be able to write that in code is to wait or retry. No intermediate value leaks. This is very similar to CPU atomic instruction. CPU analogy, this will click. At the CPU level, there is an instruction like lock inc memory and argument memory underscore address. That instruction locks the cache line. It increments the value. So it kind of like with the program counter, it locks that and then increments the value. Release the lock. Database are using the same idea, just higher level, slower across processes. So same principle. It's slower in database because it's in a user space already, right? So 7, why this matter for state Redux Riverpad Supabase? This connects directly to your earlier confusion. Redux atomicity simulated by single-threaded reducer execution. So in Redux, atomicity is simulated by a single thread or only one reducer run at a time. Only one reducer run at a time. Riverpad, atomicity is per provider. Provider recomputation is isolated. No shared mutable state. Database, atomicity is enforced by locks or MVCC. Different layers, same goal. Prevent interleaving that breaks correctness. So all of that goal is not to sniff on that critical section and then to wait or retry to prevent interleaving that breaks correctness, or in the case of Riverpad is to prevent the loop. Now, why some things cannot be atomic? You mentioned wiki edits, perfect example. Why this cannot be atomic? User A edits paragraph 1, then user B edits paragraph 3, then user C deletes sentence 2. This is semantic, human-driven, non-local. There's no single math operation that captures intent. It's kind of like, it's not like with database that has one operation, math operation that captures the intent of that command or what the user trying to do. So we need conflict resolution, version history, CRDT or OT. Or manual merges. Atomic operation only works when the update can be expressed as deterministic function of the old value. Deep connection to your state is a graph understanding. Atomic operation are local, node scope, so this is how it relates to state when we're talking about Riverpad. The atomic operations there are local, node scope, or in the node structured, or node node scope. That's the right word, node scope. Non-observable mid update. Just like a provider recomputing a Redux reducer, a CPU pipeline stage. So the CPU pipeline stage is where the program counter like lock it, or where it will become finished after the execution, like after it is being ready to commit to a register, or to store it under the register and then return to memory. In all cases, observers see either before or after, never during. That's in the invariant. Sentence you can use in an interview. The update is atomic not because plus one, but because the database executes the entire read, modify, write cycle as a single indivisible operation under its own concurrency control, preventing any interleaving.